So here we've got a nice indice problem. We've got to work out values of x such that 16 to the power of x, all in brackets, to the power of x equals 1 divided by 2 to the power of 3x. So we've got to get our x out of this function and associated values. Now I've got x here, an x here and an x here. So this is where our indice laws will come in. So if we take this side first, so we've got a number n, and that will be to the power of a, and then the whole thing to the power of b. What that is equivalent to is n to the a times b. So let's deal with that one first. So let's rewrite that using this indice law here. So here our a and our b are both x. So x times x, as here, is just x squared. So let's write that 16 to the x squared equals 1 over 2 to the 3x. Okay, now the next indice law we can look at is if we have a number n to the power of, let's say, call this a again, and it's a reciprocal. So we've got 1 over n to the a. This is the same as saying n to the minus a. So that is also another reciprocal and indice law together that we could apply for the right hand side of our equation. So let's use that on this one now. 16 to the x squared equals 2. Now we've got a 3x in our indice there, so our a can now become minus a. So we've got minus 3x. So that takes care of that. So we've got 16 to the power of something, 2 to the power of something. So we're a little bit stuck at the moment. But if we could get these into the same base, that way then we could do some algebra on them, which is going to really help us. So could we write 16 as a 2 to something? Well, we know that 16 is the same as 2 to the power of 4, because 2 times 2 times 2 times 2 is 16. So let's rewrite this 16 as 2 to the power of 4. So now we've got 2 to the power of 4 to the x squared equals 2 to the minus 3x. So we're back to where we started here, except we've got something to the power of 2. So now what we can do is we can go back to our original indice law that we introduced and rewrite that using this indice law. So now we've got 2 to the 4x squared equals 2 to the minus 3x. Okay, now that's really helpful. Now with the same base, these powers must be equivalent. Because if you have 2 to the power of something, another one 2 to the power of something, these powers must be the same. So if I have 2 to the a equals 2 to the b, a must equal b. So that's another indice law we can approach here. So therefore we've got 4x squared equals minus 3x. So let's write that up here. 4x squared equals minus 3x. Okay, now what we need to do now is just solve for x, and we've got our solutions. So let's do that. So if we set it to 0, we can perhaps factor it and find a result. So bring the 3x onto this side. So 4x squared plus 3x equals 0. Okay, now let's factor out our quadratic. This is basically a quadratic term. So we're going to get two solutions. So we can take out an x, and then taking out an x from there, we're left with 4x. And an x from here, we're just left with positive 3 equals 0. So now we've got either x equals 0 or 4x plus 3 equals 0. So this one is already solved for us. That's the solution there. That's a trivial solution. But now we've got this one here, which gives us our proper solution. So subtract 3 from both sides. So therefore, divide by 4, x equals minus 3 over 4. So these powers are x equals minus 3 to the 4. So that's going to be our second solution and our interesting solution. So we've got x equals 0, which is trivial, and x equals minus 3 to the 4. Now when that is an indice, let's write this up on here, n to the minus 3 over 4. That's the same as writing 1 over, now get a root symbol here and put our n in it. Now using this property here, we have this now as a fourth root, and our n is cubed. So that's what we would get there. 1 over the fourth root of n cubed is n to the minus 3 over 4. And that'd be a good place to start.